Any of you signed up for this course?
We have binary. We have decimal. And everybody knows what decimal numbers are. We also have bits and bytes. These two are related as we know decimal numbers 1, 2, 3, 4, 5. Decimal numbers are numbers with decimal points, for example, 125, 23. The numbers to the left of the decimal is the whole number. That's what we're going to be focusing on in this lesson. The first number to the right of the decimal is the tenth place holder. So as we know, decimal is base 10. Which means that we have 0 through 9. We have 9 or 10 symbols that represent 1 through 10. 0 through 9. So that, we get 100, 1,000.
And we know we use that for counting, money, and statistics. A couple other things. Somebody owes me $30. We're going to put that on the decimal line. Now we're going to go into binary numbers. Binary numbers are numbers which represent binary numbers were designed for computers and electronics as they're very logical devices. As I stated, they're either on or they're off. Binary digits are known as bits. So we discuss bits, and an arrangement of bits or 8 bits equals 1 byte. So if anybody ever heard of, it's an 8-byte system, 16 bytes, 16 bits, anybody ever heard of that? So we have Windows 7, which is a 64-bit system, which means that, when you relate it to the binary, that's how the coding is going to work. And we use key symbols, which increases the speed, memory, and utilization of the computer. So when we come out with Windows 7 or Windows 7 Express, they just kind of rearrange the coding to make it run faster. Applying binary to the count. So as I said, using decimal numbers is very simple. We're going to use the number 107. 1. Okay, my fault, looking this way. The 1's column is represented by the 7. The 10's place is represented by the 0s. And the 100's place is represented by the 1. So we have 107, which can be done because we have 10 numbers that can be used. We count from right to left, so we know that it's 0 to 10. Hundreds to thousands. Somebody want to give me some more money? It's so cool. Thousands to millions, millions, and everything else. So the concern or the question that we may be asking is how we're going to be able to represent 107 only using 1s and 0s. So we're going to go into our multiplication tables. These are some examples everybody should know. 2 times 1, which is 2. 2 times 4, which is 8. The reason why we're going over this because when we start discussing binary and we go into it further, we'll see that exponents in the multiplication tables
have a lot to do with how we set up our chart to start converting the binary numbers. Right to left, columns increase showing the numbers of 2. So we're going to have a brief class or group activity to show you the very basic understanding of binary numbers and how to formulate or convert a binary.
From decimal to binary and binary to decimal. So the number that we have here is 128. In the previous slide, I discussed that we have the two multiplication tables or exponents. So 2 to the power of 0 gives us 1. And it doubles over going to the left, showing the powers of 2. So 2 to the power of 1 is 2. 2 to the power of 2 or 2 squared. Or 2 squared gives us 4. 2 cubed gives us 8. 2 quads gives us 16. I don't know what they call the 5, but we'll just make that one up. That gives us 32. 2 to the 6 is 64. 2 to the 7 is 128. So it's 128 bits or 7 bytes. So now, if anybody can give me a quick discussion, who thinks or knows where to put the first digit to get 128?
64.
Now that gives us a total of 128. This is just basically to show how simple
It is to convert. There's a lot more that we'll discuss in tomorrow's lesson when we go into adding, subtracting, and negative numbers. But for right now, this here is 128. So if I add the zeros, yes.
I got it. Go.
I don't want to write, it's going to keep going over,
Yeah,
so I'm going to put it
got it.
over here. So if we have 2 to the 7th going over, yeah, that's not going to work as well as I thought it would. But hey, we got to improvise as educators. What can we do? So we have 2 to the 7th.
Like, what are we supposed to do?
We have 2 to the 0. Second, 2 to the 3rd, 2 to the 4th, so on and so forth. So as you said, we'll put the first one here, followed by the rest of the zeros. So we should have 8 digits in total. 1, 2, 3, 4, 5, 6, 7, 8. Now just imagine this was evenly aligned under there, it'll show. So now we have 107. So does anybody want to take a guess at how we will convert 107 into binary? Yes.
I think. You have to add either you would do the 2 and the 6 plus the 2 and the 5. Can you add them?
Yes, it's all about adding.
All right,
It's
so
all
the
about
64 and
adding.
the 32 is going to give me 96.
Okay, so we have a 0, we have a 1 for 64.
Okay.
Do we have another one?
No.
So we have a 0?
It's got to be a 0 because I already have 96 and I only want 107.
Mm-hmm.
Is I
Yeah,
on the
you're
right
absolutely
track?
right. You're absolutely right. So what you want to do is put, for every 1 is going to equal your number. So if you put 1 here, we have a 64. What plus, so we have 107 minus 64.
Okay.
7, 8, 9, 10. So 7. My math is terrible.
43, right? 43? Yeah. 43, so then I need the 32.
32.
That's, okay, and then I'm gonna need the 8.
The 8. So we
And
put
the 2
another
and a
one under
1.
the 8. I'm sorry, it's a little bit difficult because I would like for it to align, but every time it goes under, it kind of...
Hold on 1 second. This is the way that this one's going to work. So if we're going for 128, this is what... Alright, so at the end of the day, we're going to fast forward a little bit, and if we can basically see the answers were the same, going across, that's the way it could work. I'm sorry I wasn't able to get those printouts, the printer had jammed, and students were acting up. But for the most part, this is our basic introduction to converting binary to decimal, and when you guys come tomorrow to get the rest of your career technical education, we will go further in depth numbers, in addition to converting them for negative numbers. Now, I hope that this is something you look forward to because the future is used for technology. So far,